Although confidence intervals and p-values tell us different things, they are estimated using the same theory. In this video, we try to explicitly show the link between them. So we've talked about two ways of making statistical inference. First, using a confidence interval. This gives us a range of plausible values from which we are a certain amount confident will contain the true parameter. Typically, we use a confidence level of 95%. And second, we have hypothesis tests, where the p-value tells us the strength of evidence against the null hypothesis. So it may have occurred to you that these two are closely related. You can see from the basic form of the equation for the confidence interval and for the equation for the test statistic that's used to get the p-value that both are based on the point estimate and on the standard error. So let's show the link with p-values graphically. We've seen that under the null hypothesis, the z test statistic is distributed like this. Here's the null value, 0, and z just measures the distance away from the null value in units of standard error. We've also seen that if z is equal to 1.96, then we get a p-value of 0.05. And that's calculated as the area under each of the two tails. We know that when we estimate a 95% confidence interval, we also throw our arms out, or the error bars out, 1.96 standard errors in each direction from the point estimate. So if we estimate a 95% confidence interval and one of the limits falls exactly on the null hypothesis value, then we know that p-value will be 0.05. Likewise, if we estimate a 95% confidence interval and the limits do not touch the null value, then the p-value must be less than 0.05. And likewise again, if we estimate a 95% confidence interval and it captures the null hypothesis value, we know that the p-value must be greater than 0.05. This same logic applies for a 90% or a 99% confidence interval. So for example, a z test statistic of 2.58 would correspond to a two-sided p-value of 0.01. To estimate a 99% confidence interval, therefore, we throw our arms out 2.58 standard errors. So if the 99% confidence interval does not capture the null parameter, then we know the p-value must be less than 0.01. And we can write what we've just seen as so. You only need to remember one of these and the rest will follow. So stop the video if you want to read them.